In this video, I'm going to cover solving linear inequalities. Okay, so there's two parts to this. First is you need to solve it. And the second part is you need to graph your solution. Okay, so I want to talk about firstly how we go to solve it, and then I'll spend a little bit of time on exactly how we go about graphing it, because a lot of pupils fall down on the graphing side of this. But first, what I want to do is just go back over exactly what this kind of inequality notation actually means, so we're crystal clear in our understanding of what this notation and all the different forms of the inequality notation actually mean. Okay, so here are your four different notations of inequalities. The first one is greater than. So for example, 3 is greater than 2, because the big part is at the 3, the smaller part is at the 2. So it reads 3 is greater than 2. Less than, minus 9 is less than minus 7. If you consider on your number line, of course, minus 9 is lower down, so it's less than minus 7. So the less than, the smaller part of the inequality sign is at the smaller number. The bigger part of the inequality sign is at the bigger number. So watch out for the negatives, that sometimes can throw pupils. Think of your number line always. The lower down it is, the smaller it is, okay? Minus 7 is up higher, it's the higher number. Hence the bigger part of the inequality is facing the bigger number. Greater than or equal to, then same idea. You'll put your bigger side here, but this extra line means it could be greater than or equal to, and then of course the same on the other side, less than or equal to. Okay, so let's have a look at this in action. So back to our example here. This is a linear inequality because you have an x with only a power of 1, okay? The minute you've got a higher power than just a power of 1, it is then a quadratic inequality, perhaps a cubic or whatever. What makes this linear to look at algebraically is there's just a power of 1 with the x, okay? So solving this, good news is it's quite straightforward, this kind of inequality. You're going to treat this as you would an equation. In other words, how you would get the x on its own for an equation is exactly how you're going to get the x on its own with the inequality. And in order to get this x on its own, you're looking at the side, of course, which has the x, and you've got to get rid of the minus 2 and the 5. So in order to get rid of a minus or take away 2, what we got to do is add 2. If you add 2 to this left-hand side, that will get rid of minus 2. Minus 2 add 2 is nothing. So if I add 2 on the left-hand side, though, like an equation, I would have to add 2 to the right-hand side, because what you do to one side, you must do to the other. So same idea here. So if I add 2 here, I've got to add 2 here, which leaves me with the 5x still. And 13 add 2 is 15. Now to get rid of the 5, 5x is the same as 5 times x. Okay, when it's attached like that, it always means it's multiply. So in order to get rid of a times by 5, we divide by 5. If I divide by 5 on the left-hand side, I got to divide by 5 on the right-hand side. And then that gives me with the x on its own, which is always what I'm looking for, and 15 divided by 5 is 3. Okay, so your answer is x is less than or equal to 3. And then we would go about graphing your solution. And you mustn't forget to do that. Even if it's not explicitly asked for in the exam, you should always graph your solution with an inequality. Okay, I'm going to talk about that in a minute, because there is one thing I've got to highlight here. This, as you can see, is a lovely process, very, very similar to your solving equations. And that is the way you'll treat it. There's just one thing you have got to watch out for with an inequality. And that is, if you have an x term that is negative, that's going to cause some problems, okay? Now there's two ways you can look at this, and I'm going to show you both ways. The first is, the minute you spot you have a negative x term, what you could do is immediately add 2 x's to both sides in order to get that negative term onto the other side. Or in other words, get rid of it being a minus 2x by adding 2x to both sides. So in fact, you're left with something like this. Leaving the x then on this side makes sure it's now positive, okay? And once it's positive, it's going to work out fine. There's going to be no issue that you have to consider. So what I would do then, keeping the x's on this side, I need to get rid of the 2 that's been multiplied and the 9 that's been added. So I'm going to get rid of the 9 first. You always leave what's attached to last. So take away 9 from both sides, and I'm left with 5 take away 9, which is minus 4. And 2x is left on the right hand side. Now to get rid of the 2, which has been multiplied to the x here, I divide by 2. If I divide by 2 on that side, I divide by 2 on that side. Minus 4 divided by 2 is minus 2. And on the right hand side, I'm left with x on its own, which is always what you want. So x is greater than minus 2. And that is the answer I'm looking for. If you didn't go about adding 2x to both sides in order to have the x term positive, then here's what would happen. Your x term stays on the left hand side and it's negative, but you still want to get obviously the x on its own. So in order to do that, you've got to get rid of this 5 and this minus 2, which is attached to the x. In other words, it's being multiplied by a minus 2. So in order to get rid of this 5, I take it away. If I take away 5 from that side, I take away 5 from that side. That then leaves me with minus 2x. And 9 take away 5 is 4. Now, to get rid of the minus 2, which has been multiplied to the x, the only way to get rid of a minus 2, which is being multiplied, is to divide by minus 2. If I divide the left-hand side by minus 2, I divide the right-hand side by minus 2, and that gives me x. And then 4 divided by minus 2 is minus 2. Now, here's where you have got to remember that if you are ever with an inequality dividing or multiplying by a negative, and in this case I'm dividing by a minus, then what must happen is the inequality sign must flip as well. And that's something then that you have to always remember when dealing with your inequality. If you're dividing by a negative, or for some reason in your solving you're multiplying by a negative, that is always something that will flip the inequality sign. And so your answer then is x is greater than minus 2, which is exactly what the answer is here. X is greater than, the bigger side is to the x is greater than minus 2. You always read from the x. X is greater than minus 2 or x is greater than minus 2. Both answers are the same. So whichever strategy you want to go with, either you've got to remember to add your terms to both sides so you're not left with a negative x term, and so then you can go ahead and solve as normal, or you leave it as it is, but you remember that if you're dealing with a negative x term and you're dividing by a negative, then that will cause the inequality sign to flip. So back to our original example, and as I said, there's the first element, which is solving, and we've dealt with then the issue that might arise with solving. The second element to the inequalities is then graphing your solution. Okay, so what your question will have in it is, for example, solve 5x minus 2 less than or equal to 13. There will also be an added bit of information which will let you know that either x is an element of n, x is an element of z, or x is an element of or. N is telling you that the answer is an element of the natural numbers. Z is telling you that the answer is an element of the integers, and or is telling you that the answer is an element of the real numbers. Okay, so what are the differences between these? So the natural numbers are your positive whole numbers. So 1, 2, 3, 4, 5, 6, and so on. They are positive and they are whole numbers. And so on the number line, this is how you're going to graph your solution. It'll always be on a number line. On the number line for the natural numbers, you will use dots. Okay, and you will only obviously dot positive whole whole numbers. The set of integers, which is denoted by Z, are your positive and negative whole numbers, okay? So it includes all the negatives and 0 and all the positives as well. So again, because they are whole numbers, you will use dots on your number line if it's an element of the integers, but you will include any negatives that might satisfy the inequality as well. Or then, and this one kind of is the one that causes most problems for people, and this is the real numbers. And the real numbers are the positives, the negatives, the decimals, the fractions, everything, okay? So this is why we've got to use a thick black line. We can't use dots because we have to include the values that are between numbers, okay? All those decimals and fractions that are between numbers. So that's why we use a thick black line. Okay, so watch out for this though. Here's two nice little examples. Say you are representing x is less than -2 on the number line, but x is an element of the real numbers. Then obviously we need a thick black line, but we cannot include -2 because it doesn't have a less than or equal to sign on it. So what we do in that instance is we circle it, but we don't colour it in. And then that is everything less than -2 that is included in the inequality. On the other hand, if you have x is greater than or equal to 4, and x is an element of the real numbers, then here we can include the 4 because we have that or equal to line. So we can include the 4 and everything bigger than 4. So in this case, we will circle the 4 and colour it in because we can include it, and then obviously anything greater than 4, it's an element of the real numbers, so therefore it's a thick black line. Okay, right, let's try graphing some. So back to our example, and we got x is less than or equal to 3. So I'm going to show you the 3 different answers if it is given x is an element of n, x is an element of z, or x is an element of or. So the first one, if they had clarified in the question that x is an element of n, then putting x is less than or equal to 3 and x is an element of n on the number line would mean that I need all the numbers that are smaller than or equal to 3. But if I'm only talking about the natural numbers, remember, are positive whole numbers. So I can include 3 because I have the or equal to sign. Less than 3 then would be 2, and I can include 2. It is a positive whole number. And I can include 1. 1 is less than or equal to 3, and it's a positive whole number. But I can't include 0 because 0 is not part of the natural numbers, nor is -1, -2, or -3 are not part of the natural numbers. The natural numbers are only positive whole numbers. So the only solution graphically for x is less than or equal to 3 and x is an element of n is 1, 2, 3, represented by dots on my number line. If then you had x is an element of z, this would be different. Again, we have x is less than or equal to 3, so I can include 3, and I'm using dots as well. Dots we use for the integers as well. 2 also is less than or equal to 3, so is 1, but this time I can include 0, -1, and -2, and -3, and that's all I have on my number line. Otherwise I will continue going less, because less than or equal to 3, everything less than or equal to 3 is included. And I can include the negatives and 0 here because the integers are the positive and negative whole numbers. And lastly then, if it had x as an element of the real numbers, how would this be different? So straight away, because it's the real numbers, this is where we use a thick black line, or I'm going to use a red line in this situation. So again, I can mark 3. It is less than or equal to 3, so I can colour in 3. And then I'm going to use a thick line for everything less than 3, because your real numbers don't just include the whole numbers, it's all the decimals and everything in between. And so therefore I use the thick line for everything less than or equal to 3. All right, so there are your 3 different answers depending on whether you're told it's a natural number, an integer, or a real number. Right, let's try an example. Okay, try this question. 1 minus 2x is less than or equal to 5 and x is an element of the real numbers. Okay, pause the video, give this a go yourself, see how far you get. Try graphing it as well. And if you need a little bit of help, play the video, or if you're just checking that you got the answer at the end, see if you get it right. Or if you need a little bit of help, play for the first couple of lines and then maybe stop and see if you can finish it off yourself. Okay. So, have you spotted that we have a bit of a situation here because we have a negative x term? Okay. So, 2 ways to do it. Now, obviously you don't have to do 2 ways. You decide yourself which way you are more comfortable with. But since I'm not sure which way you've decided to do it, I will do it both ways. So the first way would be to straight away add 2x to both sides so that we're not dealing with that negative 2x. And so I'm left with 1 less than or equal to 5 and 2x. And now I'm good to go. I'm going to deal with my x's on the right hand side, getting the x on its own. And so I want to get rid of the 2, which is attached, in which case I'll leave it till the end, and the 5, which is being added. So I'm going to take away 5 from both sides first, and that gives me minus 4. That's gone. 2x. And then in order to get x on its own, I'm going to divide both sides by 2. And so I'm left with x is greater than or equal to, minus 2. So there is my answer. If you did it this way and you took away 1 from both sides first, and then you're left with the minus 2x, which of course is your issue, then what you need to be very mindful of is the minute you go and divide by that minus 2, because that minus 2 is being multiplied to the x, the only way to get rid of it is to divide by minus 2. Then when you're dividing by a minus, that is going to flip that inequality sign. And I'm getting then the same answer. X is greater than or equal to minus 2. X is greater than or equal to minus 2. So now we'll graph. So since we are dealing with the real numbers, we are talking about a thick line here. So for x is greater than or equal to minus 2, I circle minus 2. Because it has the or equal to sign, I can colour that in. And then it is greater than. So I'm including everything then above with the thick line. So try this one. Pause the video, solve it as best you can, graph it on the number line, and then replay to see if you are right. Okay, with this one you have x's on both sides. So if you remember how you would deal with that if it was an equation, anytime you have x's on both sides, you must get rid of x's completely from one of the sides. And it's easier always to get rid of the fewer amount of x's, which in this case is the 3x. 3x is less than 5x. So it's easier for me to get rid of the 3x's completely from that side. I can't have x's on both sides. I've got to have and be able to be left with just x on its own on one side, whether I'm solving an equation or an inequality like this. So my first step is always to take away x's completely from one of the sides. So take away 3x from that side. If I do that, of course, I've got to take away 3x from that side. That then gives me 5x take away 3x is 2x. I still have 7 on that side. There's my inequality. And although that's gone, because 3x take away 3x is nothing, I'm still left with 3. Okay, so now I'm looking to get the x on its own, of course. So I want to get rid of the 2, which is attached. In other words, it's multiplied, and the plus 7. So always get rid of the easier bit first, which is the plus 7. In order to get rid of plus 7, I take it away. If I take away 7 on that side, I've got to take away 7 on that side. That's gone now here. And so what I'm left with on the left-hand side is 2x. And then less than 3, take away 7. 3 take away 7 is minus 4. And then to get rid of the 2, which is being multiplied, I got to divide. 2 divided by 2 leaves me with 1x. If I divide by 2 on that side, I've got to divide by 2 on that side. So I'm left with x is less than minus 2. Okay, let's graph. And so this time x is an element of the integers, which means we're using dots. X is an element of the integers and it is less than minus 2. The smaller part is by the x, which means x is smaller than minus 2. So what's smaller than minus 2? Well, smaller than minus 2 is minus 4, and I can include minus 4 because the integers include the positive and negative numbers. Minus 3 is less than minus 2, so I can include that. But I cannot include minus 2 because there is no or equal to sign. So that is where I have to stop. The only numbers that are integers that are less than minus 2 on this particular number line are minus 3 and minus 4. Okay, try this one. Again, pause the video, see how you get on with it. And so with this one, what I'm going to do first is multiply out my brackets. So 4 times x is 4x, 4 times minus 2 is minus 8, less than 3x minus 4. So now I've got x's on both sides again. I want to get rid of the fewer x's completely from one side. I can't have x's on both sides. So I'm going to take away the 3x's completely from the right hand side. If I take away 3x's from that side, I've got to take away 3x's from that side, and that leaves me with x minus 8 is less than minus 4. And now to get x on its own, I've got to get rid of the minus 8, and the only way to get rid of minus 8 is to add 8. If I add 8 to that side, I've got to add 8 to that side. So I'm left with x is less than minus 4 add 8 is 4. So x is less than 4, and x is an element of the natural numbers. Okay, so let's sketch this on the number line. So it's the natural numbers, which means I'm using dots, and the natural numbers are the positive whole numbers. So what positive whole numbers are less than, smaller than, the smaller side is to the x, smaller than 4. So the positive whole numbers that are smaller than 4, I can't include 4, I don't have the or equal to sign. So the next one smaller is 3, put a dot, 2, put a dot, 1, put a dot, and that's where I've got to stop, because I cannot include 0, minus 1, minus 2. They are not what is considered to be the positive whole numbers. They're obviously negative. We don't include 0 either. The natural numbers are the positive whole numbers, 1, 2, 3, 4, 5, 6, and so on. Okay. So try this question now. There's a lot of negatives here, so be careful, okay? But see how you can get on with it yourself. Pause the video and give it a go. Right, well, in this question, because I have x terms on both sides, I'm going to do as I've done before, and I'm going to get rid of the fewer amount of x's completely from one side. Now, which are the smaller amount of x's? I have minus 2x's here and I have minus 5x's here. Which is the smaller number? Minus 2 or minus 5? Well, it is minus 5. Minus 5 is lower down the number line, so that is a smaller amount of x's than minus 2x's. So the easiest thing for me to do here would be get rid of minus 5x by adding 5x. Minus 5x, add 5x is nothing, so it's gone. So if I add 5x to that side, I'm going to add 5x's to that side. So what does that leave me with? Well, the minus 4 is still there. Minus 2x, add 5x is a positive 3x. The inequality sign is greater than, and minus 10 is left on the right hand side. And what this does, you see quite nicely, is leaves me with a positive x term. So I don't have to worry anymore about that inequality. I can solve it now as I would an equation. So the way I would go about it, of course, solving it like an equation, is to get x on its own. And so I want to get rid of the minus 4 and the plus 3, which is being multiplied because it's attached to the x. So always leave anything attached till the end. So I'm going to get rid of the minus 4 first by adding 4. Minus 4 add 4 is nothing, so it's gone. But if I add 4 to that side, I've got to add 4 to that side. So that leaves me with 3x is greater than, and minus 10 plus 4 is minus 6. And now to get rid of the 3 that's being multiplied, do the opposite. Divide by 3 on that side, and so I must divide by 3 on that side. And so that leaves me with x is greater than minus 2. Okay, so let's sketch this then. X is greater than minus 2 and x is an element of the real numbers. Now, because it's the real numbers, I'm going to use a thick line. It is greater than minus 2, so I want everything bigger than minus 2. So circle minus 2, but I cannot colour that in because I don't have an or equal to sign. So I can only include numbers greater than minus 2. I cannot colour that in and therefore include minus 2. So I'm going to do my thick line from minus 2 upwards. So all numbers greater than minus 2 are included, but I cannot colour that in. It cannot be included, the minus 2 itself. So there is my answer graphically to that. Okay, final question. So what if you're given something that looks like this? All right. This often causes pupils quite a few problems. The easiest way to probably tackle something like this is to separate this out into two inequalities, because that's essentially what you have all together in one line. When pupils try and solve this, and you can solve it all together in one go, but it usually causes a lot of problems. So the easiest approach, I think, to keep things simple and clear for yourselves is to always, if you have two inequality signs, just separate out into two inequalities. So the first inequality would be this one, and the next inequality would be this one. Okay, so now let's solve. So we want to get x on its own. It happens to be on the right hand side, so we just want to get the x on its own on the right hand side, and so we want to get rid of the plus 1 and the 4 that's attached, in other words, being multiplied. Leave that always till the end. We'll get rid of the plus 1 first by subtracting 1 from that side. That will get rid of it. If I take away 1 from that side, I got to take away 1 from that side. So what am I left with? I'm left with 4x here greater than minus 7 minus 1 is minus 8. And now to get the x on its own, divide by 4 to get rid of that 4 that's attached, in other words multiplied. If I divide that side by 4, I got to divide that side by 4. And so that leaves me with 1x, and minus 8 divided by 4 is minus 2. So that's the first part of my answer. X is greater than minus 2. And now this side. So this one's a little bit more straightforward in that I'll take away 1 from both sides like that here, and I'm left with 4x is less than or equal to 21 minus 1 is 20. To get rid of the 4, I divide by 4 on both sides, and then I'm left with x is less than or equal to 5. So that's the other element of my answer. So now what I need to do is graph on my number line with x an element of the real numbers the solution set that will satisfy both of these. What numbers will be greater than minus 2 but also less than or equal to 5. Okay, so on my number line, it's the real numbers, as I said, so we've got to use a thick line. And first off, I need to consider numbers greater than minus 2. So we'll circle minus 2, but be careful. It's greater than minus 2. I don't have an or equal to sign, so I can't circle and colour in minus 2. Minus 2 can't be included, but everything greater than minus 2 can. All the way up to 5. x is less than or equal to 5. So I can include anything then from -2 onwards, but not including -2, -2, greater than -2, all the way up along, but less than or equal to 5. So I'll circle 5. I can include 5, so I'll colour that in. And then it is a matter of doing a thick black line, or in this case, of course, red line. Between them. And there we go. That is the solution set that satisfies the number being greater than -2, but less than or equal to 5, and it being an element of the real numbers.